Hey everyone, welcome back to Pre-Algebra and Algebra 1. Last time we covered basic addition and subtraction. Now we're going to delve into two more fundamental operations, multiplication and division. So what is multiplication precisely? Multiplication is basically repeated addition. So if I had 12 plus 12, that's an addition problem. If I add another 12, that's still addition, right? 3 different times, it's still addition because all you see are plus signs. If you calculate it, you get 36 as the answer. Now, there's nothing wrong with doing it this way, but mathematicians like to find shortcuts. And a shortcut for addition, or repeated addition actually, is multiplication. Notice that all three of the numbers, or all n of the numbers, where n is the number of times you're multiplying it by, have to be the same number for you to do the repeated addition, because you're repeating the same number over and over again. Now, this symbol is called a times symbol. And the reason why is because you're multiplying it 3 times. So you're doing 12 times 3, you're adding it 3 different times. The first 12, the second 12, and the third 12. You're adding it 3 different times, which is why it's called the times symbol. Now this is still equal to 36. We still have some parts to this equation, like with addition and subtraction. The result of this multiplication problem is called the product. Like I said, the product is the result. So like how the sum is the result of an addition problem. Now, what about these two? We had addends in addition problem. These are called factors. And if you go further into Algebra 1 and Pre-Algebra as well, you'll hear that the factors of a number are the numbers that multiply out to it. The factors of 36 are technically 12 and 3. That's just two of the factors, because 12 and 3 form the factors of this equation that multiply out to the product of 36. There are a few other ways we can symbolize multiplication. Unlike with addition where it's just the plus sign, we can also do 12 and then a dot in the center and then 3. That's another way you can symbolize multiplication. It's usually more used in further levels of mathematics. It's usually the time symbol that's used in Pre-Algebra and Algebra 1. So that's what I'm going to use in these videos. You can also use parentheses, 12, and then just a 3. You can just do this and people will know it's multiplication, but it's less common. And you can also do this with a variable, 12x. You don't need any parentheses. They just know that this is 12 times x. But variables are a bit advanced for us, so I'm just letting you know. Now, what can we do with multiplication? How do we do multiplication, in fact? Well, like with addition, you're probably going to have to memorize some stuff. In addition, we used a number line, and then we jumped back and forth. Well, forth in addition, back in subtraction. With multiplication, there are tables that you should probably memorize. It's harder to do it on a number line. It's possible, probably, but I honestly prefer a table, and it's just something you should do with practice. Now, I can't really help you with that through a video, but it's probably beneficial to make flashcards and use those. I would recommend that. That's how I learned it. Basically, if you search a multiplication table, you'll get an image of a big table with different rows and columns for each number, and you multiply them to get the result. So an example would be, if I had this big table here, I won't draw the entire thing because that takes too much time, but let's say I had the number 4 up here, and the number 7 down here. And this is the times table. There are also addition and subtraction tables. Subtraction are less common, but addition and multiplication are the most common tables you'll find. There are other numbers here too. It's from 0 all the way to usually 9, could be to 12, depends on which level you're trying to learn at. But I'm just going to focus on 2 numbers right now to tell you how it works. You see the 4, you go down until you hit this 7. And this 7, you keep on going until you hit this 4, and the point where they intersect is the number. Now, in the table, it would say 28. And if you go down, like this, you'll see that that's where they intersect. 4 times 7 would be 28. You'll notice that if I start from 4 and go to 7, it's 28. If I start from 7 and go to 4, it's 28. You might think you have to start at the top and go to the one below it, or there must be some sort of order, but actually 4 times 7 is equal to 7 times 4. And we'll get more into that in the next few videos, where we're going to talk about advanced of the operations, advanced addition, subtraction, multiplication, and division. We go into some properties. But for now, just remember that 4 times 7 is equal to 7 times 4. When you multiply two numbers, the order doesn't matter. I probably confused you there, but don't worry, we're getting there. So that's how you use a multiplication table. That's how you memorize one-digit multiplication. For multi-digit multiplication, I'll go over that in a future video. I know I did multi-digit addition and subtraction in the basic video, but multiplication requires a lot more thinking, so I'll do that in the advanced multiplication and division video. On to division. Division is probably my favorite of the operations because it's just fun to do, I guess. Division is the opposite of multiplication. It's splitting one number into another number. That doesn't sound like the opposite. It sounds like just a different operation altogether. But as we'll see in future videos, division undoes multiplication. So let's say we have 12, and this is the symbol, divided by. So it's an interesting symbol. I like it. Divide by 4. Now, you're basically splitting a group of 12 objects. So let's say there are 12 balls. You're splitting them into 4 different groups. Group 1, Group 2, Group 3, and Group 4. Now, each of them should have 3 balls each. The reason is when you add 3, 3, 3, and 3, you'll get 12. Now you see where it undoes multiplication. The answer to the division problem would create a multiplication problem. 3 times 4. 3 in each group times 4 different groups would be the total number. So that is a multiplication problem. 3 times 4 is equal to 12. The division problem is 12 divided by 4 is equal to 3. So you see how they're kind of related. Now, before I go further into this, I'm just going to go through the parts of a division problem. The quotient is called, it's the result of the division problem. It's called a quotient. There's not really a reason for that. I guess you can think it's like, it's an interesting name, kind of like how sum is addition, product is multiplication. There's really no reason for these result ones, but the actual parts of it, like the 12 and 4 in this case, makes sense. It's the divisor and the dividend. They have stuff to do with division, so it sort of makes sense. The divisor is the number dividing, so it's 4 in this case. That's something that people can mess up on. They get confused between the divisor and the dividend. The divisor, think, is the shorter one. It's only 7 letters long, while dividend is 8 letters long. So the divisor is the smaller number, usually. When you go into fractions, which is a bit further into pre-algebra and algebra 1, it's not the case, but by then you'll probably get used to which one's divisor and dividend. For our purposes, divisor is the smaller one, dividend is the larger one. And that's because divisor has less letters, dividend has more letters. That's probably just a coincidence, but it's an easy way to remember it. Now, like I said, it undoes multiplication, and we can actually use that to solve division problems. So for one-digit problems, instead of doing like table memorizing like we did for multiplication, you can reverse multiplication. So my method lets you just memorize one thing, the multiplication table. You can use that to do division. Similarly with addition, all you have to do is memorize the addition table, and then you can use that for subtraction. If you want, you can also use number lines, but on a test, your teachers are more likely to ask you to memorize stuff instead of actually drawing it because it takes more time. Now, back to this. Division is reverse multiplication. So if I had a problem like 60 divided by 12, this isn't really a one-digit problem, I would say. But I would say this is equal to 5 because I know 5 times 12 is equal to 60. And if you did memorize your multiplication tables, this one would be known because I suggest you memorize until 12. I never stop things halfway. I go 0 through 12 instead of 0 through 9. If you want, you can start at 0 through 9 and then expand to 0 through 12. I honestly think that up to 12 is good. If you want, you can even memorize up till 20, but that's a bit overachieving. Maybe over the course of your class, like one full year, you can memorize 0 through 20, and then who knows, 0 to 30 and all that. But I guess that's being a little bit of an overachiever. I think that 0 through 12 is must know for pre-algebra and algebra 1 and even further courses. So 5 times 12 you would know is 60 if you memorize the multiplication table. So you can use the reverse. 60 is the result and 12 is one of the factors. So when you have a result divided by one of its factors, you get the other factor. So you have 60 divided by 12. So the result is 60, one of the factors is 12, you get the other factor. Now you remember that 5 times 12 is 60, so 5 is the other factor you're missing, meaning the answer of this should be 5. I'll give you another example. Let me just erase all of this. Let's say we had something like 18 divided by 3. If you memorize your multiplication tables, you know that 3 times 6 is 18. That has both 3 and 18 in it, so you're pretty sure that should be what you need. You see that 18 is there, 3 is there, the one missing is 6, meaning the answer should be 6. And that's sort of how you solve division problems given a multiplication problem. And that's all I have for you in this video. Next time, we're going to be going more in depth into memorizing stuff. I'll show you some quick tables that you can use to memorize, and I can help you actually memorize them if you want. And then from there, we'll go into advanced addition, subtraction, advanced multiplication, division, and we'll continue our pre-algebra and algebra 1. So I'll see you next time.